should be able to see it now.
Yes.
So this is called O'Neill's wetsuit, and it's Hammer 3/2. Why is it called Hammer 3/2? It's because this portion on the suit, the chest, is 3 millimeters thick. The rest of the suit is 2 millimeters thick. It has a zipper on the back and all kinds of stripes and stuff. This one happens to be black, and there is a logo on the chest, O'Neill. That's what you see here. And here, what you see in the little line, that's when they order it on November 1st. They get it on January 31st from this company called Tech. And then they start selling it, and that's their selling season. And obviously, this is a bet that they have to place. And the bet is to maximize their profit at an unknown demand that will happen starting on January 31st or February 1st, when they will start selling those suits for the new season, for people who like to do water sports. They parameters for that suit, they sell them to the distributors for $190. They pay Tech $100 for each suit. And also there is a third parameter, which is called salvage value. Salvage value is $70. And the $70 is that amount of money that they get after the season is over. So that's called salvage value. Why now? Let's talk quickly about why is this called a news vendor model. It is called news vendor model because any one of you who probably saw some old movies where kids, usually boys, running around and selling newspapers on the corner, and they're yelling the main events out, and people come and pay them money for the newspaper. Now, every morning, very early in the morning, sometimes at night, these people had to buy papers from the printers. And they had to guess or make a bet. How many papers will they be selling next day? And based on that, they either made profit or they lost money. And that is a news vendor model because they need to predict the demand for this particular newspaper. And they also know that nobody will pay anything for the paper which next day after tomorrow. Nobody wants yesterday's news. So that's everybody clear. What's the salvage value of newspaper? Anybody knows? Say it. I cannot see messages at the moment.
Is it 0?
Yes, correct. It is 0. So that's what this means. So the salvage value for the newspaper model is 0. And therefore, this is something that they have to struggle with. And in this particular case, they they needed to forecast demand. And these kids did not obviously know forecasting methodology. They did not know news vendor model, but over time, with experience, they had learned certain things, and they were somewhat successful because if they weren't, they obviously would have gotten out of this business. And this is why this model is called vendor model, news vendor model. Obviously, it is the same for O'Neill's. O'Neill's has to predict, in a way, has to predict the future. They have to say that we know that that demand is usually normally distributed. That's based on their experience and their knowledge. They also know that they assume that a mean of this demand again, based on their experiences, about 3,000 suits. And the standard deviation for those things is 500? No, 1,000. 1,000. And based on that, they are trying to predict the future. So again, if you look at those three density functions, it's normal distribution density function, as you've seen it before. There are three of them on the screen. And the one in the middle is the one that practically used by O'Neill. In other words, there, as you can see, the mean of the demand is 3,000, and it shows the probability of what kind of demand will be. So 3,000 is mean, and then there is very little chance that it will be zero, or very little chance that it will be 6,000. Now, if standard deviation was 500, and that's the normal distribution density function on the left-hand side, if you look at the screen, that one is sharper and thinner, meaning that it all kind of compressed and it's closer to the predicted mean. While if you have a standard deviation, which is in this particular case, it's 1,500, then the probability is going to be much broader, and it will be more difficult to predict in this case. So those are the nuances of this thing. We will use Greek letters. So mean is letter mu, and standard deviation is sigma. And probability of what it predicts will be f of q. So let's now look at another presentation of the function of normal distribution. This is a different representation. It is the same thing. It is distribution f of q. You can see that it is starting at 0, and it goes to 1, just like probability always is. 3,000 is the mean. It means that 0.5 probability it is lower, and 0.5 probability is higher. And this is usually called S curve. And basically, on this curve, we can study graphically the behavior of demand, and we can predict. Let's say we can say if value of demand is 3,000, f of q, f of 3,000 means that its probability is that the demand will be equal or less of this value is 0.5, and it will be higher than 0.5, that demand will be greater. So that's basically the statistical component of this whole thing, and it is not terribly complicated. It's just the different presentation of probabilities, normal distribution. We also will be using a table that, as always, if there is a graph, you can also build a table, and the table will look like this. Everybody can see the table in front of them?
Yes.
Hello? Good. So the table, well, there are actually, it's one table with 3 columns, and each of the columns has 3 columns. Right. So the first column is Q, which is the demand or quantity that you have to buy to predict the demand. F of Q is the probability of that. And no, don't pay attention to the third column for now, I of Q. We will use it later on. So as you can see, Q increments by 100. Why is it by 100? Because we don't want to make table too big. So it's incrementing every time by 100. And if we look again, if we look at the Q, which is equal to 3,000 over here, we see that f of Q is 0.5. And that means that for 50% cases, the Q will be equal or less than demand, and for 50%, it will be higher than demand. So that's basically what this thing means, and that's the table which we will use, and we also will use the graph sometimes to explain things. Now, is somebody whistling? Oh, their microphone is doing this. Now, again, by looking at this table, we can see that if we know that demand is distributed normally with mean 3,000 and sigma being 1,000. So if we look at a Q, which is, let's say, a 500, which if we decided to buy 500 suits, the probability that demand would be less or equal to 500 is very, very small. It's 0.0062. Okay, because mean is 3,000. The mean is pretty high. On the other hand, if we look at Q, which is, let's say, 5,000, which is very high, the probability, if we bought 5,000 suits, the probability that demand would be equal to 5,000 or less than 5,000 is 0.9772, which is very high. So this is what basically probability and the relationship between selection of number of suits we are buying and probability relationship is. So based on experience of O'Neill's, they know that in 50% of the cases, for any of their products, the probability that they guess the number properly is only 50%. So it is really a very complicated game. In other words, if they predict that the mean is 3,000, then it is that there will be something in the middle of, if you predicted this 3,000, then the fact that demand will fall either 3,000 250 and 3,000 minus 250 would be only 50% of the situation. So that is basically the game that they're playing, and that's why it is very complicated. So if we get to closer to start looking at the model of this, we need to understand that this situation is quite complicated, and it requires a lot of effort from a point of view and experience, from a point of view of prediction and knowing the demand, but also it is something that we never really can predict for sure. And the situation will be changing with time. Just 1 second, I lost the presentation. Yeah, I know. So let's check with our file where we are. So the model represents the challenges faced by people in combination of uncertain demand with the flexibility of supply. Once you've chosen, this is something that you have to live by when the time comes, and that's what makes it. There are overage and underage. We're going to define it a little later. There are definitions for it. Now, the critical ratio, that's the typo in the presentation. Critical ratio balances the two types, and we're going to talk about what critical ratio is. So the quantity is seldom the mean of the demand. We also will understand of that. The slides are kind of a little lousy, but we'll follow to see what they do say. Yeah, we're going to come back to this later. So we just talked about the salvage value. Those are the important definitions to have. We talked about salvage value, which is the value at which we're going to sell the product after season expires. And salvage price and cost represent economic parameters of news vendor model. So you always have to have those three. Then the density function is something that people determine by figuring out the basically based on their experience. They're declaring that this is going to be normally distributed process, and they are trying to maximize their profit on it. So, and then what we now will do, we'll define two definitions, two important figures for news vendor model. One is called underage cost, and the other one is called overage cost. And I think I will just show to you what they are. In our case, what is underage cost? Underage cost is what would we lose as far as our cost is concerned if we underguessed by one suit what demand is. In other words, we're predicting that mean is 3,000, let's say. And then when the demand occurred, the customers wanted to buy 3,001. If you knew that customer is going to buy 3,001, then you would have bought, and for another $100, you would have bought that suit, and you would have sold it for $190. So in this particular case, what happened is that you lost an opportunity to make profit. Let's get to, maybe I can write on this so that we don't have to lose it. Okay, very good. Maybe I'll write on here. So the underage cost, what we do, we designate it as C sub U, and in our case, it is $190 minus 100, which is cost, and 190 its price. And for us, it's going to be $90. So that's very important economic value. So you all understand, we didn't lose $190, but we lost the profit that we would have made if we bought 3,001 suits. On the other hand, the overage cost, and we designate that with the letter C sub O. The overage cost means that what happens if we buy one extra suit and we don't sell it? It ends up in salvage. What happens in this case? Let's say we bought 3,000, but our demand was 2,999. So if we knew that, we would not spend our $100, but we would also not get $70 salvage value. So in this case, we determine C sub O as we did not spend $100, which is our cost, and we did not make these $70 of salvage. That's the price that we charge a discounted price. So C sub O is equal to $30. So those are two key parameters that we calculate based on economic values given to us at the beginning of modeling process. So you always will be given a cost, you will be given a price at which you pay to vendor, price what you do, you charge your customers, and you are giving salvage value. So in any problem that you solve, it always will be like that. You will be given those things. Okay? Now, with that in mind, we can go to the next slide. That's convenient, eh? Something new. No, it is not better to overbuy. We will get to it. It depends on the value, and that's what this whole activity is about. You have to guess, just like with EOQ, if you remember, we came to the Q asterisk, and we found that that value maximizes expected profit. And that's what we were looking for. The same will happen here in this model. Let me talk about the fact that it is perishable. The fact is that technically any item, the clothing that you buy, except maybe item staples like socks or whatever, the people always want to have newest model. This is like fashion business. The wetsuits are just like fashion business, and people who are doing it on a regular basis, they tend to buy, the young people, they're sometimes a little flashy, and they want to buy the latest and the greatest for the season. Just like people want to buy latest and greatest t-shirt or jeans. So that's why wetsuits represent perishable product. You know that there will be some demand for it because young people always want to do waterboarding or what is it called? It's not waterboarding. It's called something else. Wakeboarding. No, but I forget what it's called. Windsurfing and surfing. So the surfing, that's what it's called, surfboard. So, and the water usually, where there are waves, the water usually is pretty cold. So you need to have a wetsuit, and you pretty much want to buy it every season. And that's why it's considered to be perishable. Okay? Clear? Let's move on then. So the next thing which we're going to look at is something that, knowing those two things, we're going to define another value, and that value is called critical ratio. Critical ratio, that's not rate, it's a critical ratio, is the formula that is expressed this way. That's, again, I do not like slides for this chapter. But the formula is expressed like this. It's a critical ratio. Critical ratio means that at Q asterisk, in other words, if we buy Q asterisk of suits, wetsuits, the probability that demand will be equal or less than Q asterisk is equal to this ratio. And that is this ratio is named as a critical ratio. It's a ratio of cost of underage divided by cost of overage plus cost of underage. And that is very, very important ratio. It's just like we started capability index, and we started coefficient of variation. This is very, very similar as far as basic notion of news vendor model. Now, what's important, there is a way to figure this out, this ratio. I'm not going to do it because it is clear. It can be done. It's just a regular algebra. how you figure out this ratio and how you get to it. But what's more important is to understand what this ratio is, and it's called equation 13.1 because there's probably like 5 or 6 equations in this chapter that you will need to know. What I want to do is I'd rather show you a graphic representation of it, and hopefully that will be clearer. And we will do it by going back to sharing application screen. Let's do it from here. Okay. And this is what it looks like. By the way, this is an interesting table that shows the critical ratio parameters for 3 different processes. One is the O'Neill's hammer 3/2 suit that we just covered. And these are pharmaceutical capacity with vaccines, which is very, very apropos for our coronavirus season. And this is distribution center staffing. So when you have free time, it's important to kind of just represent and understand those values. Now, what I want to show you is this graph. So basically what this graph shows is something intuitive, but when you capture it, it makes it easier to understand. So if, let's say, you know the distribution of your process is normal distribution with mean 3,000 and sigma 1,000. If you bought 0 suits, if you bought close to 0, you know that you would, if you bought an extra suit, your first suit, you would have definitely made $90 with almost 99% probability. You would be able to sell this suit at $90. Now, if you keep buying, you're buying a second suit, you still probability that you will be able to sell it knowing that your mean is 3,000 is very high. So as you keep buying from 0, and your probability of being able to sell it starts going down a little bit because it is a random process. You can never be sure, and probability that you will be able to sell this suit is lowering, and it's lowering until you get to a certain point, and that point actually bypasses mean value. And at this point, you will go as you buying 3,000, 4,000. So the probability of selling all of those suits is diminishing, and at 6,000, it's almost 0. It's similar to the normal distribution curve. If you recall, when we had the normal distribution curve, it would be that at the value 6,000, you already have probability 0 that this will sell. In other words, a lot of those suits will end up in salvage value. Now, from expected loss point of view, just like C sub O, you will see that if you bought 0, and you didn't sell anything, you don't lose anything. Now, if you buy 1, the probability that you will lose something is very, very low. If you buy 1,000, probability becomes a little bit higher. If you become 2,000, it's a little higher. If you buy mean, the probability that you lose also will be a little bit higher again. And so on and so forth. Again, at some point in time, it will cross the expected gain curve, and it will go up to your $30 that you salvage when that's what you, if you bought 1 extra, if you bought 1 suit less, 1 suit extra, 1 suit more than you actually were demanded. So those 2 curves are called expected gain and expected loss. What's interesting, they are crossing at the point which is approximately something like 3,700. And that is the value where your expected gain is equal your expected loss. And based on that, that's how your critical ratio is made. And the critical ratio is very, very important because what critical ratio allows you, let's go back to critical ratio allows you to do is, it's kind of a unusual phenomenon. It puts economic values in the relationship with the probability of success of your prediction. For people who gamble, it might be very meaningful because that's a similar thing, because you're based on values of loss and gain, you will be feeling more risk averse than if the values are slightly different. So that's why I think it is very important that news vendor model has a lot of other interpretations, not just for buying, but it could be used in gambling as well, if you're interested in that. So let's select this line. Let's go to our other thing here. So that's basically what this ratio is. And it's very important for us to know that somewhere at some point in time, based on that intersection, that's where we will hopefully, we cannot get our gain any higher because now it's going to diminish, and we cannot get a loss any lower. Therefore, they are equal to each other, and this is how we get to our value. In our case, for our specific model, we can calculate that, and let's quickly do that as well. Let's share a screen. Oh no, I can write here maybe. Yeah, this is much more convenient to write on this one. So, as we have in our case, we know that C. Can I write here? Yes, I can. I forgot to take a pencil. So we know that C. Oops. C underage, cost underage is $90, and C overage is $30. So critical ratio in our case would be 90 divided by 30 plus 90, and it is equal to, anybody knows?
0.75.
0.75. So what does it mean? It means that with these economic values, the probability that demand will be equal or less than equal to the Q asterisk, and we will find what this Q asterisk is. The probability is 0.75. So again, significance of this thing is, and why it is called critical ratio, is because it determines and it shows to you the connection between two not obvious, not very intuitive worlds of existence. One is the probability that demand will be less than certain number, equal or less than certain number that you predicted. And the other side of it is economics, which is pure data based on cost, price, and salvage value, which is quite an incredible thing. Which means that if you interpret this, it means that when you know that normal distribution has mean of 3,000 and sigma 1,000, and the economic values are 100, 190, and $70, you will be able to find this equation, this economic ratio, and you will know that by predicting certain Q asterisk, probability that you predicted demand will be either less or equal to 0.75, which is quite interesting. The other, and that you predicted less than demand, the probability obviously is 1 minus 0.75, so it's 0.25. So it's quite significant. Now, what is that? Let's just think a little bit more from what this ratio also captures. So, for example, when is it good for us to buy a mean value? In other words, when Q asterisk could be a 3,000. Anybody knows? That's correct. Excellent. A point for correct answer. Obviously, if C sub O and C sub U are extra credit, yes, you will get it on the final exam. So C sub O plus C sub U, they are equal to each other, then the value of this ratio is 0.5. So then what it means that mean could be that Q asterisk. So when the salvage, when the overage cost and underage cost are similar. On the other hand, when the probability could be equal to 1 or close to 1. But how about that? That's more difficult, right? The question is when the f of Q asterisk will be close to 1. When C sub O is 0 or close to 0. Exactly. So if the difference between our cost and the salvage value is 0, then your probability, you can buy the probability that demand will be equal or less of what you bought will be almost 1. So you can buy a lot if there is no salvage value in this case. You can buy a lot because it just everything gets sold. So that's the meaning of that. Okay, so now let's quickly talk about two things. How we can calculate this Q asterisk, and there are three ways to calculate Q asterisk. The first way is by graph. If you have a graph, which is your density function, let's go back to this. Let's share. I try to quickly do it so we don't lose a lot of time on this. It's not that simple. It could have been done better. Okay. So there are three ways of doing it. One simple way, and there is by the way, just to mention, in your books, in this chapter, there are several exhibits. The exhibits are step-by-step process how to find the Q asterisk, and they are expressed exhibit 13.1, and then there is exhibit 13.2. But for our purpose right now, this is what I want to show you. So this is the distribution function. It has mean 3000. And in order for us to find out the critical ratio of the Q when the demand is equal or less 0.75, having this graph, what we're going to do is that we're going to go on probability axis, which is vertical axis. We're going to go and find 0.75. And then we're going to go horizontal line across, parallel to axis X, cross the line, our distribution line, and drop it down perpendicularly to the axis X. So the value of Q asterisk is 3,700, meaning that if you bought 3,700 suits, the probability that your demand will be either equal to 3,700 or less is 0.75. So Q asterisk is guaranteeing you expected maximum profit in this case. So that's the method number one. Method number two is the graph, which we looked at before. The table. It's the graph is intuitive, but not easy to use. Where is my table? No, not here. Is it here? Yes. Here it is. So the graph is intuitive, but you never have the graph because you cannot draw this distribution function very accurately. That's why you have to go and find the table. This table was created specifically for normal distribution with mean 3000 and sigma 1000. So again, the way you do it is that you look for you look at f of q function, which is second column, and you find the value, which is 0.75. In this case, there are two q's. One is 3,600, and then f of q is equal 0.7257, and 3,700, which is 0.7580. In this case, we round up. The value is rounded up. So we are not picking Q as 3,600, we are picking Q asterisk as 3,700 because round up rule works in this case. So this is the second method of identifying optimum Q asterisk value. The only problem with this particular table is that it is not universal. It's only for that particular normal distribution. But it's in this case, what we have to use standard normal distribution table. Anybody knows what standard normal distribution is? Everybody's quiet. Standard normal distribution table is the table for normal distribution with mean 0 and sigma 1. It's a key, it's universal key for normal distribution, because if you know this, if you have that table, you can always find the answer for any normal distribution. And that's very important to understand. So when you have standard normal distribution table, and the table looks slightly different, it doesn't say Q, it says Z instead of Q. And I will show you this table now. And I will talk about how to use this table. This is the case when and that's the table 13.4. And it is for standard normal distribution. In other words, it's not specific to what our normal distribution is. It's universal. You need to know how to convert parameters in this case. And the way you do it is this. Again, you look for probability 0.75. And you find the probability of 0.75 in the second column. And it corresponds to Z value. And by the way, Z, because it's symmetric to 0, Z could be minus and Z could be positive in this particular case. But that's not, because there is no real normal distribution for suits, buying suits of standard normal distribution. So you always have to convert the result from this table to the normal distribution of specific item that you're looking for. So in this particular case, you're looking at 75. Again, 70. There is here 72.57 and 75.80. You round up, so you select the Z value, which is 0.7, not 0.6. And what you do next is as follows. Let's go back. Stop. You remember 0.7 we've selected. Stop sharing, go back here, go back here. I wish there was a smoother way to get back to your slides, which I haven't figured out yet. Okay. Okay, so here's what you do in this case. So what you do is that in order to find value Q, you use the formula, which in this case is formula Q here. It's formula 13.2. Okay, let's get the pen. And this is what this formula is. And what it means is that we just found from the universal table 13.4, we found the value Z, and Z was equal to 0.7. We utilize this formula to find actual value of Q for our normal distribution. It's Q asterisk is equal to mu, in our case, is equal to 3,000. That's a mean value, plus Z 0.7 multiplied by sigma, which is 1,000. And obviously, this becomes the same, 3,700. Shouldn't surprise anybody that the value is exactly the same. Now, just to make sure that for the future, there is a third method of finding Z, and the third method is utilizing Excel spreadsheet in your computers. And while you have computer and know how to use it, this is better and much faster. In this case, you just calculate Z by utilizing this formula, and this is the critical ratio value. In our case, it's 0.75. So you put this here, and it gives you Z. In this particular case, Z, by the way, would be slightly different from Z 0.7, because this table, the Excel spreadsheet table, is a lot more accurate. It's not every 100. So the value would be something smaller after you calculate Q asterisk. It would be something like 36, I forget, 40 something too. So it is a little bit more accurate. But the bottom line here is that that you have to know that on the exam or in any situation in real life, when you have to utilize the table, or if you do not have an Excel in front of you, you will use universal table for standard normal variation, and you will use the formula 13.2 to convert it into real Q asterisk. So that's basically what we covered for today. I was hoping to cover more, but we will have to then cover it next time and talk as fast as we can because I do not want to get too much behind the schedule. Okay? Any questions before we leave? We have 3 minutes.
Professor, you said that we have to worry about part 4 and 5 in chapter 12 of chapter 11.
In chapter, which we're covering now, chapter 3, chapter 13, right?
So you said we don't have to worry about part 4 and 5, yeah?
Yes.
Okay, thank you.
We'll finish this chapter next time, and we will finish it at section 13.3. So the 4 and 5 we will not cover in this chapter. And housing market is not going to crash. And even if it crashes for a while, it will come back. We all, you were little, but I lived through September 11, and people thought at the time that housing market in Manhattan will never come back. Smart people at that time went and bought a lot of property. I have a few friends who sold their apartments a couple years ago and made millions. So it will be back. Nothing crashes forever. Yes, I wish you lots of luck and success. No, the stocks are a lot more complicated than the critical ratio. And the techniques, the intelligent programming techniques are not perfect even today. Nobody can predict the future. So I thank you all for your time. I appreciate your participation. You have to be more active. There is only 1 or 2 people who participate. The rest of you guys just taking it easy. You all have a good day and have a great the rest of the week.